Hey, so if you're just starting out on your programming journey, that's awesome. Welcome. But hang on a second. Before you dive headfirst into Python or try to build that first website, let's just pause because, to really master this stuff, you got to understand the machine you're talking to first. And that's exactly what we're going to break down right now.
So I've got a question for you. Do you actually understand the machine you're about to program? I mean, really get it? Because here's the thing. Programming is so much more than just typing code into a screen. It's all about giving super clear, super precise instructions to a machine that, well, it doesn't think. It just does exactly what you tell it to do. All right, here's our game plan for this explainer. We're going to cover the story of computers, what's going on inside the machine, how the OS acts like a manager, the way the internet works, and then the big one, what your role as a developer is in all of this. Okay, let's kick things off right at the beginning. I mean, to really get a grip on modern computing, we kind of have to look back and see how we got here. And what's cool is, we're going to uncover this one single core idea that has never changed. Think about it. We started thousands of years ago with the abacus, right? Just simple beads and rods for counting. Fast forward to the 1800s, and you've got Charles Babbage dreaming up a machine that could follow instructions all on its own. Then boom, the 1940s hit, and we get ENIAC, a beast of a computer that took up a whole room. And now, you're holding a smartphone in your hand that's literally millions of times more powerful. It's wild. But here's the crazy part. There is one single thread that connects every single one of those things, from the ancient abacus right up to your phone. And it's this. No matter how complex they get, the basic rule is always the same. Computers follow instructions. That right there, that's the foundation for everything we're about to talk about. All right, so let's peek under the hood inside the machine. Probably the easiest way to think about how a computer is put together is to just compare it to a person, to the human body. So first up, we've got the CPU, the central processing unit. This is the brain. Simple as that. Every instruction you write in your code, every time you click a button, every little thing that happens in an app, it's all handled, it's all executed by the CPU. And remember, it's not thinking, it's just doing. Next is RAM, which stands for Random Access Memory. You can think of this like your short-term memory, or even better, think of it as your desk space. When you've got a ton of browser tabs open, that's your RAM keeping them all active and ready to go. And when your computer starts to get sluggish, that's probably your RAM getting full. You've run out of desk space.
And rounding out our core components is storage. If RAM is the disk space, storage is the computer's long-term memory. It's the big filing cabinet. This is where all your files, your operating system, and all your apps are saved permanently, even when you shut the computer down.
So how do all these parts work together? Well, every single computer, no matter what, follows one simple cycle. Input, process, output. That's it. You type something on your keyboard. That's your input. The CPU crunches the numbers on that command. That's the process. And then the words pop up on your screen. That's the output. It really is that simple. And here's the key takeaway for you. As a developer, your real power, your whole job, is to control that middle step, the process. You are the one who decides what happens between the input and the output. That is programming. Okay, but wait. There's this huge, powerful layer of software that's managing all this hardware for you kind of behind the scenes. And you know it well. It's called the operating system, or just the OS. Yeah, you're already totally familiar with these guys. Microsoft Windows, Mac OS, Linux. But trust me, they're doing way more than just giving you a pretty desktop and some icons to click on.
Yeah, behind the scenes, the OS is like this master manager, a real traffic cop. It's deciding how much CPU time each app gets, it's handing out RAM to whoever needs it, it's organizing all your files, and it's making sure all the different hardware parts can actually talk to each other. When you just click to open an app, the OS is handling all of that insane complexity in like milliseconds. Okay, so we've got one computer running perfectly. That's great. But how do billions of them talk to each other all across the globe? Well, that, my friends, brings us to the internet. At its core, it's actually a pretty simple conversation. When you go to a website, your computer is the client. It sends out a request, basically saying, hey, can I have the information for this web page? That request travels to a really powerful computer called a server. The server grabs what you asked for, processes it, and sends the response right back to you. Now, for this massive global conversation to happen without just falling apart, it needs rules. These are called protocols.
And you can just think of them as the traffic rules for data. Things like HTTP, that's the language web browsers and servers use to talk, and TCP/IP. That's what makes sure all the little packets of data actually get to the right place. Seriously, without these rules, the internet would be absolute total chaos.
All right, we've talked hardware, we've talked operating systems, we've talked networks. So the big question is, where do you, the developer, fit into this whole picture? Well, it's simple. You're the translator. Here's the most fundamental truth you have to get. Computers understand exactly one language: binary. That's it. Zeros and ones. On and off. They don't get words, they don't get complex ideas. Not on their own, anyway. And that is where programming languages come in. A language like Python or JavaScript or Java, they're just human-friendly translators. You write instructions in a way that makes logical sense to you, and the language does the hard work of translating all of that into the zeros and ones the machine can actually understand and execute. So if we had to define programming in one sentence, it's this. It's giving clear, logical instructions to a machine that never, ever guesses. That's the part you gotta remember. If your logic has a mistake, the output will have a mistake. If your logic is perfect, the machine will do its job perfectly. Every single time. And this is why just jumping straight into the latest, fanciest framework can be a big mistake. Before you do any of that, you really, really need to get these fundamentals down. How the machine actually works, how it handles memory, how networks talk to each other, and just how all these systems communicate. Because here's the payoff. When you truly understand the whole system, from the metal of the hardware all the way up to the network, you stop being someone who just writes lines of code. You start designing architecture. You start solving real, complex problems. That's when you become a true developer. Okay, before you take off, I'd love to hear from you. Drop a comment below and let me know. What programming language are you thinking of starting with? Did this whole breakdown of the fundamentals actually help clear things up for you? And what should we dive into next? Let's figure this all out together.